Hi everyone, welcome back to another video in the Web Security Academy series. In today's video, we'll be covering lab number 6 in the JWT attacks module titled JWT Authentication Bypass via KID Header Path Traversal. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy. Select all content and then all labs. And then do a search for the JWT topic and go to lab number 6 titled JWT Authentication Bypass via KID Header Path Traversal. Alright, let's get started. This lab uses a JWT-based mechanism for handling sessions. In order to verify the signature, the server uses the KID parameter in JWT header to fetch the relevant key from its file system. To solve the lab, forge a JWT that gives you access to the admin panel at /admin, then delete the user Carlos. You can log into your own account using the following credentials, and we're giving credentials of a regular user account. So essentially, we've got an application that handles sessions using JSON Web Tokens. And in the JSON Web Tokens, there's a KID parameter that defines which key is used to sign the token. And so what we need to do is find the flaw in the way the JSON Web Token has been signed or has been implemented, and then use that flaw in order to access the admin panel and delete the user Carlos. Okay, let's access the lab. Now notice over here, I am using the built-in browser in Burp, and so all my requests are already being passed in my Burp proxy. We will be using the JWT editor extension, which we've used in previous labs, and so make sure to download it under the extensions tab if you haven't downloaded it yet. All right, the first thing that we're going to do is log in with the credentials that we were given. So the password was Peter, hit login. And notice over here right away the requests are in the color green, and the reason behind that is that the JWT editor extension is identifying that there is a JSON Web Token in these requests. So if we look over here, the first one is the login request. It takes in the CSRF token, the username and password. If the username and password are correct, the application sends you to the My Account page, and it sets a session cookie in your browser, and that session cookie is a JSON Web Token. So if you go to the JSON Web Token tab, you could see the decoded token right over here. So what I'm going to do is I'm going to access a request that has the JSON Web Token in it, send it to repeater, and work from there. Let's close this off so that we have more space. Now, again, we're at the My Account page of the regular user. If we go to the JSON Web Token tab, you could see there is a KID parameter in the header. There's the algorithm, we're using symmetric encryption. There's the issuer, which is portswigger, the expiration date, and the subject, which is our regular user. Now, if we go back to our notes from previous labs, so far we've learned 5 different techniques on how to potentially exploit JSON Web Tokens. We're going to assume that we've tried all 5 techniques in this lab and they didn't work, and so now we're going to try our 6th technique. In this technique, we're going to check if the KID parameter is vulnerable to path traversal, or also known as directory traversal. Alright, now some servers may use several cryptographic keys to sign different kinds of data, and so the header of the JWT may contain a KID parameter, which stands for key ID. This parameter helps the server identify which key is used when verifying the signature. Now, the JWT specification doesn't really define a concrete structure for this ID. And so it could technically be any arbitrary string of the developer's choosing. Now, if this parameter is vulnerable to directory traversal, an attacker could potentially get the server to use an arbitrary file on the server's file system as the key to sign the token. Now, how is this useful to us as an attacker? Well, all the operating systems have default out-of-the-box files that we already know the content of. And so if we could get the server to use a file that we already know the content of as the signing key, then we could alter the token as much as we want and sign it with the key that is equal to the content of the file. Now, this attack will only work if the application is using symmetric algorithm, which we can see over here. It is using a symmetric algorithm. And so we're going to try out this attack vector in the lab to see if it works. To do that, we're first going to change the subject to administrator. And actually, before we do that, we need to confirm that there is an admin panel. So if you click on send right over here, we get a 200 OK because we are accessing our own homepage. Now let's see if there's an admin directory in the application. So let's say admin, hit send. And if we look at raw response over here, you get a 401 unauthorized. And if you render over here, it says the admin interface is only available if logged in as the administrator. And so we definitely have an administrator account. So we're going to change the subject to administrator. Now, if we try to send this request over here, it won't work because the signature doesn't match the signature that will be generated in the backend and compared to the one that we have in the token. And so we're going to use our 6th attack vector to try and see if this is vulnerable to path traversal and hopefully sign it with a key that we're already familiar with. And so we're going to try and sign it with the dev null file. So that's /dev/null. The dev null is called the null device file, and it's present on most Linux systems. It's essentially an empty file that returns an empty string. So we're going to try to get the application to use the content of this file as a key, which is essentially just an empty string, and it's /dev. The way it was written before is incorrect. All right, so to do that, we don't know where the key file is located on the server. And so we need to get out of the directory to the parent directory on the server. And so we're going to use the string over here, which essentially means move up one level in the directory hierarchy. To be on the safe side, we're going to use multiple ones to ensure that we actually go to the parent directory, and then we're going to call the dev null file. All right, this looks good. So now what we're saying is use the content of the dev null file as the key that is used to verify the JSON web token. So now we essentially need to sign our JSON web token with the empty string. If you are using the JWT editor extension, which is what we're doing over here, it won't allow you to sign tokens using an empty string. But to get around this feature or bug, you could use a base64 encoded null byte. So if we go to decoder over here and say AA equal to sign, that's a base64 encoded version of a null byte. So if we decode over here as base64 and we say text over here, it's simply just an empty string. And so we're going to do that using the JWT editor extension. Let's delete the default key so that we don't get confused by it. And then click on new symmetric key, and it doesn't matter what the size is. Click on generate, and under the K attribute over here, we're going to add our base64 encoded null byte, which is again AA equal to sign. Click OK, and then we're going to use this key over here in order to sign our token. So if we go back to repeater over here, click on sign, and then use the key that we just generated. Click OK. Now the signature has changed. So essentially what's going to happen right now is when we click on send and try to access the admin panel, if this KID parameter is vulnerable to directory traversal, it'll fetch the content of this file, which is the null byte, and then it'll use it to sign the token. Now, once it's signed the token, it'll compare the signature that is generated in the backend with the signature that we have over here, which was also used to sign the token using the null byte. And so the signatures are going to match. Once the signatures match, it'll allow us to access the admin panel. So if we go over here and click on send, we should get a 200 OK unless we've made a mistake. And here we go. So if we look at raw over here, we get a 200 OK message. And we render, you could see we've got access to the admin panel, and we're allowed to delete any user that we want. Now, to complete the lab, we do need to delete the Carlos user. So let's do a search on Carlos to see the path to delete that user. And it's right over here. Click copy. And then hit send. And we get a 302, which is a good sign. It means that we've deleted the user. So if we follow redirection over here and we render, you could see the Carlos user is no longer available. And over here it says, congratulations, you solved the lab. All right, so we successfully completed the exercise by exploiting the path traversal vulnerability in the KID parameter. In the next lab, we'll look at another test case that you could apply when testing for JWT-based vulnerabilities.